Hi, in this video, we're going to start chapter 4. We're going to be working in chapter 1. Okay, I'm looking over at the notes for chapter 4. We're going to be working and talking about probability. And just want to start off with different ways. We already have like a feeling about what probability is. And I'm going to lay out a probabilistic structure, and it has got to sort of make sense to us for it to be useful and helpful. But there's a few different ways to think about probability, and I have in the notes 4 of them that I just want to connect about with for a moment. So an empirical probability is the probability of seeing something occur, repeating an action over and over and over and over again, and determining what the percentage or the probability of a particular outcome of that experiment is. So in particular, I have this example here, empirical probability, right? So an empirical probability, the example is to estimate the probability of tossing a coin and getting a head. Toss the coin 100 times and count the number of heads. Say there's 42 of them. Then the empirical probability of getting a head is 42 out of 100. Okay, so in general, we'll repeat the experiment many times. And so we have this denominator, the number of trials of the experiment. And then we want to count up the number of times a particular thing or an event has occurred. We'll go through some definitions a little bit too. So empirical probability is sort of tied to a repeated experiment. Okay, and the second kind of probability we want to think about is this classical probability. And so the classical probability is you make some kind of assumptions about how experiment outcomes of experiments will what the probability structure is. And in particular, we consider the outcomes, the situation where the outcomes are equally likely. So that would be what we mean by a fair coin. The probability of it landing on a head is equal to the probability of it landing on a tail. And the classical probability counts up the number of ways a particular event can occur and divides by the total number of possible outcomes. So these probabilities are more mathematical. We'll be working more with these classical probabilities, okay? And another way of sort of thinking about probability is, so it's similar, the simulated probability is similar to the empirical probability. So a simulated probability is when maybe I don't want to toss the coin 100 times, but I'll go on to Excel and I'll ask Excel to toss a coin 100 times. And so sometimes probabilities are difficult to calculate, like the structure that the classical probability might bring to us might yield a lot of difficulty in mathematics to calculate a specific kind of probability. So we could simulate it by, setting up a number of different random situations in a software system and seeing how many times our desired outcome occurs. So sometimes the probabilities are difficult to calculate, and the experiment can be simulated on a computer. So if we simulate an experiment multiple times, this is similar to the empirical method, right? Okay, and so then the final way I want to bring up about probabilities is this idea of a subjective probability. So subjective probability, things we think, how we think. If I asked you, what's your probability that it's going to rain today? Okay, it's probably a subjective guess, right? Maybe depending on what you saw when you walked out of the house this morning, if you walked out of the house this morning, if your roommate left the house with an umbrella, you know what I mean? Like it could be all kinds of things that come in and into play with respect to what you really think the probability of rain is going to be today. So sometimes these subjective probabilities don't always follow the mathematical requirements of a true probability. So for example, a subjective probability is a person's estimate of a chance event occurring. It's based on personal judgment. It should always be between 0 and 1 because we are talking about probability. And but it may not always observe all the laws of probability. So for example, 90% of the people consider themselves better than average drivers. All right. So I just want to look a little bit at what we mean by classical probability. So here are, here's a display of outcomes when you roll a red die and a black die. So there are 36 possible outcomes, and when I lay them out in this kind of way, each of these outcomes is equally likely to occur. Okay, so the red one has it, because it's fair, is equally likely to spin a 1 through a 6, and the black one is equally likely to spin a 1 through a 6. And it should be noted that this 1 red black 3 is a different outcome than 3 red black 1. And it also should be noted that even if we didn't see the colors, that this outcome is really different than that outcome. All right. Note, it might also be worth noting is that red 2 black 2, it only occurs one way. All right. So black 2 red 2, red 2 black 2, it's the same outcome. All right. So for dice, the classic, and we'll be working with this, so you have to kind of get used to the dice and the card experiments here. So what is the probability of rolling 2 dice and the sum is 4? We're just going to look, and we see that 3 and 1, 1 and 3, 2 and 2, and 3 and 1. So there are 3 ways we can get a 4 out of a total of 36 possible outcomes. So 3 out of 36. All right, and this is just a picture of a simulation. 2 computers simulate the tossing of a balanced coin. So you can go in and ask Excel to give you either a 0 or a 1, and the 0 might associate with the head, and the 0 with the tail, and the 1 with the head, so that the proportion of heads is going to be the number of 1s in the data set. All right, and so you can see that what happens as we simulate is that it's kind of variable initially, but then it settles in to its long run average of 0.5. And it could look different, but they have the same long run averages. And so again, a way to calculate the probability for equally likely outcomes. If an experiment has n possible outcomes and all of them are equally likely to occur, then the probability of any one outcome is 1 over n. If an event can occur in more than one way, and we'll kind of visit these definitions again, so give me a moment and just kind of listen. That if F ways that we can get a certain event to occur, then the probability of that event occurring is F over capital N. So in the dice experiment, F was 3. It was the number of ways we could get the dice to sum to 4. And the capital N was 36. So we had 3 over 36. And that was the probability of rolling 2 balanced dice and having the sum equal 4. Okay. That's it for this section. I'll see you in the next video.